There are several possible explanations for burnt light boxes in a fire-damaged house. Firstly, electrical arcing and overheating. Faulty wiring or loose connections can create arcing, which generates intense heat. This heat can ignite flammable materials such as the insulation and wires within the light box. Secondly, a lack of grounding or bonding. Proper grounding and bonding create a path for excess electricity to safely dissipate. Without proper grounding or bonding, electrical faults can lead to accumulation of excessive current, causing arcing and overheating. Thirdly, overloaded circuits or fixtures. Attaching multiple appliances or lights to a single circuit can overload it. This can cause excessive heat buildup, which can ignite flammable materials in the light box. Fourthly, heat accumulation. In areas where the fire did not reach the sheetrock, heat can still accumulate and radiate from other sources. This heat can be conducted through electrical wiring and reach the light boxes, causing them to ignite. Fifthly, poor ventilation. Poor ventilation can trap heat within the walls and attic, causing temperature buildup. This heat can reach the light boxes and ignite flammable materials. Sixthly, smoldering combustion. Electrical faults can cause smoldering combustion, which generates heat over time. This heat can eventually ignite the insulation or wires within the light box. Seventhly, recessed lighting. Recessed lighting fixtures create enclosed spaces where heat can accumulate. If the fixtures are not properly installed or ventilated, they can overheat and ignite the surrounding materials. Eighthly, inadequate insulation. Insufficient insulation can allow heat from fires to penetrate walls and reach the light boxes, causing them to ignite. It is important to have a licensed electrician inspect the electrical system of a fire-damaged home to determine the exact cause of the burnt light boxes and address any underlying electrical issues. Electrical arcing is a dangerous phenomenon that can occur when electricity jumps between 2 points through the air. It generates extremely high temperatures, often exceeding several thousand degrees Fahrenheit. This intense heat can rapidly ignite nearby flammable materials, posing a significant fire hazard. Electrical arcing can be caused by a variety of factors, including damaged or frayed wiring, loose connections, and corrosion. Over time, the insulation surrounding electrical wires can degrade, exposing the conductive metal underneath. When this happens, electricity can escape from the wire and arc to a nearby grounded object or another wire. Loose connections can also create arcing because they provide a gap for electricity to jump across. Corrosion can form on electrical contacts, increasing resistance and generating heat, which can eventually lead to arcing. Grounding and bonding are essential safety measures in electrical systems. Grounding provides a path for fault current to flow back to the source in the event of a short circuit or other electrical fault. This allows the circuit breaker or fuse to trip, cutting off the power and preventing a dangerous buildup of voltage. Bonding connects all metal parts of the electrical system together, creating a common ground potential. This prevents voltage differences from developing between different metal parts, which could create a shock hazard. Without proper grounding and bonding, electrical faults can lead to a dangerous accumulation of current, causing arcing, overheating, and potentially electrocution. Overloaded circuits are another common cause of electrical fires. Every electrical circuit is designed to handle a certain amount of current. When you plug too many appliances or lights into a single circuit, the current can exceed the circuit's capacity. This can cause the wires to overheat, which can melt the insulation and ignite nearby flammable materials. The amount of current a circuit can safely handle is determined by the size of the circuit breaker or fuse that protects it. Circuit breakers and fuses are designed to trip or blow when the current exceeds their rated capacity, preventing the circuit from overheating. However, if the circuit breaker or fuse is too large for the wiring in the circuit, it may not trip or blow in time to prevent a fire. Heat accumulation can also contribute to the ignition of light boxes, even in areas where the fire did not directly reach the sheetrock. Heat can be conducted through electrical wiring and other metal components, transferring it to the light boxes. In enclosed spaces, such as walls and ceilings, heat can become trapped and build up over time. This can raise the temperature of the light boxes to the point where they ignite. Poor ventilation can exacerbate the problem of heat accumulation. When there is inadequate airflow, heat cannot escape from enclosed spaces, leading to a further increase in temperature. This is especially common in attics and walls, where insulation can restrict airflow. Smoldering combustion is a slow, flameless form of burning that can occur in materials such as insulation, wood, and fabric. It is often caused by low levels of heat that are not sufficient to ignite a flame. Smoldering combustion can generate a significant amount of heat over time, which can eventually ignite nearby flammable materials. Electrical faults can cause smoldering combustion by creating a small amount of heat that is sustained over a long period. Recessed lighting fixtures can create enclosed spaces where heat can accumulate. If the fixtures are not properly installed or ventilated, they can overheat and ignite the surrounding materials. Recessed lighting fixtures are typically installed in ceilings, which can trap heat and restrict airflow. Inadequate insulation can also allow heat from fires to penetrate walls and reach the light boxes, causing them to ignite. Insulation is designed to slow the transfer of heat, but it is not completely effective at stopping it. If there is insufficient insulation, heat from a fire can quickly pass through the walls and reach the light boxes. To determine the exact cause of burnt light boxes in a fire-damaged home, it is essential to have a licensed electrician inspect the electrical system. A qualified electrician can identify any underlying electrical issues that may have contributed to the fire, such as faulty wiring, loose connections, or overloaded circuits. It can also assess the condition of the grounding and bonding system to ensure that it is functioning properly. Once the cause of the burnt light boxes has been determined, the electrician can recommend the appropriate repairs and upgrades to prevent future electrical fires. This may include replacing damaged wiring, tightening loose connections, installing new circuit breakers or fuses, and upgrading the grounding and bonding system. In addition, it is important to ensure that all electrical work is performed in accordance with local electrical codes. These codes are designed to protect people and property from electrical hazards. By following these codes, you can help to ensure that your home is safe from electrical fires. When dealing with fire damage, it is also important to consider the potential for smoke and soot damage. Smoke and soot can penetrate deep into building materials, leaving behind a lingering odor and potentially causing health problems. It is important to thoroughly clean and decontaminate any areas that have been affected by smoke and soot. This may involve using specialized cleaning products and equipment. In some cases, it may be necessary to replace damaged building materials. It is also important to address any water damage that may have resulted from firefighting efforts. Water can promote mold growth, which can also pose health problems. It is important to dry out any wet areas as quickly as possible and to remove any mold growth. Fire damage restoration is a complex process that requires specialized knowledge and skills. It is important to hire a qualified restoration contractor to ensure that the work is done properly. A qualified contractor will have the experience and expertise to assess the damage, develop a restoration plan, and complete the work in a safe and efficient manner. When selecting a restoration contractor, be sure to check their credentials and references. It is also important to get a written estimate before work begins. Electrical safety is paramount in any home, but it is especially important in a fire-damaged home. By taking the necessary precautions, you can help to prevent future electrical fires and protect your family and property. Remember to have your electrical system inspected regularly by a qualified electrician. Be sure to address any electrical problems promptly. Avoid overloading circuits. Use the correct size circuit breakers and fuses. Install smoke detectors and carbon monoxide detectors. Have a fire escape plan. By following these safety tips, you can help to create a safer home environment. It is crucial to understand the role of arc fault circuit interrupters, also known as arc fault circuit breakers, or FSIs. These breakers are designed to detect dangerous electrical arcs, which are a common cause of electrical fires. They are more sensitive than traditional circuit breakers and can detect arcs that may not be large enough to trip a standard breaker. FSIs work by monitoring the electrical current for unusual patterns that indicate the presence of an arc. When an arc is detected, the FSI quickly shuts off the power to the circuit, preventing a fire from starting. The National Electrical Code requires a size in many areas of the home, including bedrooms, living rooms, and dining rooms. If your home does not have a size, consider having them installed by a qualified electrician. Another important safety device is a ground fault circuit interrupter, or GFCI. GFCIs are designed to protect people from electrical shock. They work by monitoring the electrical current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out, it indicates that some of the current is leaking to ground. This leakage current could be flowing through a person who is touching a live electrical wire or wet surface. When a GFCI detects a ground fault, it quickly shuts off the power to the circuit, preventing an electrical shock. GFCIs are required in areas of the home where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. It is also important to be aware of the dangers of aluminum wiring. Aluminum wiring was used in many homes built in the 1960s and 1970s. However, it has been found to be more prone to corrosion and overheating than copper wiring. If your home has aluminum wiring, it is important to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend any necessary repairs or upgrades. One common solution is to use copper pigtails to connect the aluminum wiring to electrical devices. This reduces the risk of corrosion and overheating. Surge protectors are another important safety device. Surge protectors protect electronic devices from damage caused by voltage spikes. Voltage spikes can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from electronic devices, preventing them from being damaged. It is important to use surge protectors on all electronic devices, especially computers, televisions, and appliances. Smoke detectors are essential safety devices that can save lives. Smoke detectors are designed to detect smoke and sound alarm, giving people time to escape from a fire. It is important to have smoke detectors installed on every level of your home, including inside and outside of bedrooms. Test your smoke detectors regularly to ensure that they are working properly. Replace the batteries in your smoke detectors at least once a year. Carbon monoxide detectors are also important safety devices. Carbon monoxide is a colorless, odorless gas that can be deadly. It is produced by the incomplete combustion of fuels such as natural gas, propane, and wood. Carbon monoxide detectors are designed to detect carbon monoxide and sound an alarm, giving people time to evacuate the building. It is important to have carbon monoxide detectors installed on every level of your home, especially near sleeping areas. Test your carbon monoxide detectors regularly to ensure that they are working properly. Replace the batteries in your carbon monoxide detectors at least once a year. Finally, it is important to have a fire escape plan. A fire escape plan is a plan that outlines how to safely evacuate your home in the event of a fire. It should include multiple escape routes, a designated meeting place outside of the home, and instructions on how to call the fire department. Practice your fire escape plan regularly with your family so that everyone knows what to do in the event of a fire. By following these electrical safety tips, you can help to protect your family and property from electrical hazards. Remember to have your electrical system inspected regularly by a qualified electrician. Be sure to address any electrical problems promptly. Avoid overloading circuits. Use the correct size circuit breakers and fuses. Install arc fault circuit interrupters, ground fault circuit interrupters, smoke detectors, and carbon monoxide detectors. Have a fire escape plan.